worked out, by the way. So, in this one, they've actually drawn you a diagram. So if they haven't, then it would be a really good idea to draw yourself a little sketch of what's going on. And you're not always going to know that it is a trick question, but in these instances you will, because that's what we're learning. So you'll know that you're always going to be drawing yourself a right angle triangle. Okay? So the cable car climbs at 48 degrees to the horizontal. So the way they work this means that this is 48 degrees. It's in the diagram anyway, but just so you're aware that if it's to the horizontal, then it will mean that this angle here is 48 degrees. And that's the mountain side. BC is 52 meters, so just that bit at the bottom is 52, and DE is 37. Calculate the total length of the cable AC. Is there anyone that can suggest how we might do this? Don't rush. Label the sides. What would you like to label them? Okay, so initially we need to decide what we're actually... So yes, we are going to be doing that as soon as we establish where our right angle triangle is, because can you all see that we've got two right angle triangles here? Yes, we've got the baby one and then we've got the big one. Hey, Emily, you also had a hand up. What do you think we might do? Okay, watch that. I've thrown it into you so much that the first thing we do is the trick question, they were fun. This, not so much. So we have to just think practically. What's going to happen? We need to know this length here. Any suggestions?
I don't know if you would need this, but never mind, you wouldn't need it.
Oh, you may need it. What?
Oh, you think, because I was going to say, to find the smaller, you can find the smaller triangle angles. But
Small triangle
you
angle.
can find the angles of the
missing angles.
yeah. Like speed.
You can find the whole angle. You can find now. Well,
Big triangle is like
okay.
the whole length.
Let's first of all, from this diagram, I'm going to draw two. I'm going to draw two right-angled triangles. Okay, and I'm going to draw my big one and my small one. So if this was my small one, that's the small one, yes, and then this would be my big one. Now, I can fill in this angle for both of them. I can fill in this length, oh, that's not, I can fill in this bit here, 52. Oh, that's so not A. Oh, this one's 52. This one's 52. Okay, so my BC length I know is 52, that angle is 48. Can I fill in anything on this one? Not yet, no.
You could find the angle of A.
We could find the angle A, but totally we're not so much help. Yep.
Did you understand that?
No. It meant that because I when I threw it in. Does that help anyone decide what we might have to do? Actually, which side? Hello? Let's use some letters. BD, or do you mean DC? Do you mean EC? Do you mean AC? DC. I would suggest finding DC would be helpful. Yes? The reason being is that if we find DC, then we could at least label this length here. We'll have that. If we found length DC, in other words, this big bit here, we could then label in my big triangle this length, because we can add the 37 to it. Yes? Because we're trying to find this length here, we need to have some information that we can use in this one. And at the moment we've got nothing. We've got just a little portion of it, and we've got a little portion of that. Do you want to see that? Yes? Is it because it's after lunch?
Yeah.
We haven't got a lot of museum? Okay.
This is the lesson where I calm down before I go crazy during PE. So.
Okay.
Yeah.
Great. Can we try a little bit more?
Woo!
What just just a yes, no, when we're saying the other stuff. Alright, so we're going to find this DC leg. Now what do we do, either Ashley or Emily? Now we've established that we're going to try and find this leg here. What do we do?
Label the five.
Label the 5. So we would label this one H, this one O, this one A. Which of these 3 do we not need? Oh. Is this going to be SoFar or Toa? Which length are we trying to find, the H or the A? So the length A is equal to what?
C times 8. We call it six. Really?
So, and then you're like, it's brilliant. I'm sorry, what did you say? Yes, because you guys told me to eat 10 minutes.
We make it cost.
Oh, I'm loving it even more. So A, we can A or X, doesn't matter. So what, cos what? What goes with cos? 44. Well, secretly it's 48, but I'm giving you sister. My writing is not clear on here. Multiply by, oh, tres bien, and we're going to chuck that in our calc. Now, whilst I normally say round to be significant figures, or even they might chuck in how to round stuff, if it's mid step of working, give a few more decimal places just in case it affects the final answer. And with trigonometry, it can often do that. So can I add a few more digits? Sorry, start again, please. No, add in from the beginning. 0.795.
I'm sorry.
So we now know the value of x. So what does that mean we can now do?
Find the value.
Find both. Add together so you find the
Easy.
whole
Nice.
length.
You can have it. So we know this bad boy is 34.795. So now we can label easy. Yes? So we're going to add 37 to it. And what do we get?
Like something.
51. Wait, I got 70. 30. 71.795.
71.795.
Now we can find more.
Okay, so now we've got a length on here, we've got an angle marked. What do we actually want to find?
The length
This
is
bad boy here, so we'll call that y and put it. And so now we are able to use trigonometry to find that length. Okay? But looking at it immediately, Hannah, focus this. Looking at it immediately, we couldn't do that. So what I'm saying is for these application questions is that you may have to do some additional work. It's not always a straightforward, oh, let's label H O A and off we go. Okay? So now we can label H O A. So H O A. So that, which one is irrelevant for? Oh! So that means we're using yeah. But this time we're not trying to find the adjacent, what are we trying to find? So H equals A over cos theta. Oh, this is beautiful work. Beautiful work. So So we're now going to chop our numbers in. So y equals 71.795 divided by cos 48. And we're going to chop that in our calc. We have C. And that is our total length, so we would probably round that to whatever they've asked us to, maybe 360. So, and that would be meters. Christians?
What is that little symbol?
That says 3SF.
Oh. Did we always put that?
Well, I'm just showing, because I wrote equals, equally it's not equals to it, but it is equal to it.
The
to
rounding
360
side.
figures. Well, I should do wavy things then. Okay, are we good with that? Now, part B. Now, so we haven't finished. It's all we might have done. Enables you to click on over. But all of that work was just for part A. Oh my goodness, shut. Part B says the vertical height gained from C to A. So that means that they want to know the vertical height. Well, I don't know. What's this? Do you know what that means?
Yes, the height upwards.
EA, this bit. Nice, EA, Trisby answer. Yes? So we are trying to establish the value of EA or AE. Yes?
Yeah, my calculations it's 7.
Now, you've got a couple of different ways of doing this. We have established that this length is 71.795. We've established that this length here is 107.296. Whose rule can we use to find this length? Pythagoras, yes.
See, I was right. Oh, you're kidding.
So,
I threw.
if we have two lengths already, then you can go back to Pythagoras' theorem and you can use that. Alternatively, you can go back to labeling the HOA and you can use either the hypotenuse or the adjacent in order to find the opposite side. So you have a choice which method you would prefer. Let's just go do the Pythagoras option just to make sure that you're all remembering what Pythagoras' theorem is. So, if we were trying to find length AE, we say to ourselves, first of all, is that a short side or a long side?
Short.
A short side. So our equation, our formula is going to involve a subtract sign because it's a short side. Yes? Side? Remember? Yes.
Wait.
You should totally ask a question.
Why would you wouldn't the whole length be 159? 107 or 52?
I didn't listen to it. Oh, sorry, Emma.
The whole hypotenuse wouldn't it be 152?
No, darling, because we worked out AC. Right. This we use this 52 in order to find this length here. We then transferred this length and added it to 37 to our new triangle. Now our new triangle was the big triangle. It went from A to C. So it was that whole length. So they didn't ask us to find B to A, they asked us to find A to C, which is what we did in one hit. Yes?
It would be 50,
Are you with me? Sure. Right, okay, so going back to Pythag. Oh. This is 107, what's this? No, the hypotenuse was 107.
Oh, and also, isn't reason the vertical height gained from C to A?
Yeah, so you have to do it again.
Oh, I thought you guys were saying B to A.
No, we are talking about what that means is. So I'm gonna put my big triangle on here again. So what they're asking for, Emma, is this measurement AE. That's the vertical height.
Oh, the vertical height gained from C to A?
Yeah. But
can draw a diagram.
So it's
Why does it have to trick us like that?
but this is what oh my gosh,
No, but it's just,
Sally. This is what happens. This is how they word stuff, which is why we go through some wordy questions. So the vertical height has to be this big. So the little Ujma what's it travelled up here, lovely jubbly. And he's going both horizontally and vertically, and they want to know just the vertical bit.
so now we figure out the vertical.
Yeah.
So we know that the hypotenuse is 107.
So we know this bad boy is
And E to
107.296.
C is
And this is
71.799.
there is really very was. Now, I would suggest, because it is, oh my gosh, girls, please. I know you're waiting to say something or ask me a question, and I'm totally coming to you, but one second. When we are working out stuff, ideally go back to your unrounded answer, okay? Because it may have a slight effect on the final answer. And a lot of questions assume and expect you to go back to your unrounded one, okay? Amelia, you kept trying to tell me something. What were you telling me?
Well, because I was confused when you first said it, but if you go straight up from C, you'll have like almost a complete square, and you'll just like see the other part, and you're like, oh, I see that.
Yes. Okay.
So the question isn't asking for the difference between the small square's side that we haven't found and the big square's side. It's just
No, correct. They just want to know this bit, because it's from C to A. Yeah?
107.2.
Right. Roger that. You're trying to answer the question.
No, I just
No.
want to say, it's 107.296, but when I got on my calculator, I got 100. Wait, did you like round or something? You rounded it? Oh.
But I asked Emily to give me a few digits, and so she's giving me. Normally we would stop at the 3 significant figures.
I know, but it's so rounded. It's too.
We get something because we can't. We're not going to put the whole thing in.
Yeah, but dude, why would you want to round it if you just do 295?
What was after the
Because after it was like 6 or something.
Because it was a 6, she rounded it up to 3 and 6.
Okay.
You hear me?
Yeah.
I don't know, but we're being recorded, so maybe not highlight the fact that you're bored and we're about 10 minutes into the lesson. Right, so we're trying to find length AE, so we would AE squared would equal what? Pythagoras theorem.
Wait, this is a lot. Please give me a minute.
C minus.
Now, can I just point out that you could have told me one letter? Right. I said AE because I'm talking about this length.
So AC minus
AC squared
minus EC squared.
minus EC squared. You all happy with that? How do you know that? Right, Samantha is not familiar with Pythagoras theorem. Right. How did you know that, Nash? So, do you recall Pythagoras' theorem says that the two shorter sides, squared and added, gives us the long side squared? Yep. So, if we're trying to find the shorter side, which you're happy that AE is one of the shorter sides, your formula is going to have a subtract. Because rearranging that formula means it's going to be a subtraction code on there. Now, you always have to start here with your hypothesis. Because otherwise you're going to get a negative number and you won't be able to square root it. Okay, good. Alright, so AE is going to be the square root of that. I'm going to chunk it all in now. So it's 107.296 squared, subtract 71.795 squared, and you can chuck it in without that whole thing together, should you wish. There we go.
It says
It's
295.
129.1.
So if you're gonna give it to like 3 decimal places, why
I'm
do you
just
need to
giving,
round
it's
the last
120.
thing? Can't you just keep it like that? See, because look, it was
If she's like, I'm not going to
107.295. Why can't we just say 295 instead of rounding it to 296?
Because
You're rounding it in the
But
middle.
if you've ever taken something from your screen and put fewer digits on the paper, you should always round it. Yes. Yeah. Does that answer that question?
Yeah.
And that was good.
And now I've got the answer to your third question.
Oh, why? Thank you.
Wait, so which one was it? We're just looking for the
Wait.
unsquared number or the squared number?
I would like the square rooted.
Oh, okay.
Final
129.1.
Oh, mine. Oh,
Did I do something wrong?
Yeah, you can plus it. She did plus that. Put it in the
Oh, all the way up here.
okay,
Oh,
would be 8.
oh, wrong.
Okay, this is lovely.
That was a
Okay.
lot.
79. Are we happy with that? Other people that have done it?
Wait, I'm gonna do just the
79. 736. Okay, so if we were then going to round that to 3 significant figures, that would be 79.7 meters to 3 sig. When we come to our answer, what do I know? What's I don't know the actual value of it, but what feature of this length must I know?
It's not gonna be negative.
It's not going to be negative, correct? What else do we know about it?
It's not gonna be.
If I got 115.3, is that going to be fine? Oh, Hannah.
Because it can't be longer than 107.
Good. It can't or should not be longer than 107 because that's our hypotenuse. Okay? So that's where if you've accidentally added it, you may get the wrong answer. And so when you're writing this, you need to remember that this length here has to be smaller than that one. Okay? So sometimes you may get the whole thing is that when it comes to you doing these questions, you have to look carefully as your answer sense. Okay? A sense check can often catch when you've got things right or wrong. Oh, that was quite a good long question.
Now let's cover part 10.
Three significant figures. Was that the question?
Oh, no.
Right.
What if the answer
Let's just
was?
pause this now. Example. 2 metal rods are hinged at C. A and B are attached to a vertical loop. AC is horizontal. So that information is summarized in their diagram. Okay, so we've got 2 metal rods hinged at C. So the rods are AC and AB, yes? And this is horizontal, and this is we need to calculate AB. Well, who's going to suggest how we might do that? Pythagoras is probably our best option. Are you happy with Pythagoras' theorem to do that?
Yes.
Excellent. Ida, could you please tell me what AB squared is equal to?
190 squared minus 120 squared.
Transients. Okay, we all happy with that?
Yes.
It's subtract because we are finding a short sides. We always start off with our hypotenuse.
Oh, so when you write 80 squared, you always start with the hypotenuse.
This is how I always do it. I always start with my unknown thing.
Okay.
Now, did I teach you Pythagoras or did you learn last year?
You did.
Did we do it last year and this year?
No.
We have not done it here.
We didn't learn it this year.
So you learned it last year.
Maybe.
So you may have learned that you always go into your a squared plus b squared equals c squared and then rearrange it. I don't know. Is that what you remember that? That's what you learned? Or you see now, I prefer to always start with my unknown and then decide is it plus or minus. Are we happy with doing that?
Wait, how do we know
Plus or minus.
Is it a short side or is it a long, is it the hypotenuse?
So if
I don't think I'm okay with that.
So if it's a hypotenuse, it's always add, and if it's one of the others, it's always subtract.
subtract the hypotenuse, something from up to
Yes.
I don't like
I get that. I get that.
Now, if going straight into this is freaking you out because that's not how you learned it all last year, then you can go ahead and you can write that AB squared plus 150 squared equals 190 squared, or vice versa, and then rearrange if you prefer. Okay, so if that is more comfortable for you, then please go with what you're used to writing. I don't want to start confusing the situation at this stage. But I tend to go with this.
So you know how they give us marks for certain steps that we show? Do we have to say, like, the answer is squared if you put a square root over everything?
No.
Okay. Like that.
So if you had gone straight to saying AB equals the square root of 190 squared subtract 150 squared, that's fine. Is that what you mean? Okay, so again, you can work these out baby steps on your way, but if you're doing that, don't round stuff. Keep them as long as possible. And then we square root that bad boy.
160.
Let's have a few digits. 619. Yeah? And that would be centimeters. So they want to choose significant figures. So what's this number to choose significant figures? 1. Nice. Tricky.
Why did you do AB squared plus 150?
Because that's how some people learned it last year. And I didn't want to them sitting there thinking, what the hell is she on about? Because that's A squared plus B squared equals C squared. So once you've done that, secretly that would go above this. Yeah. I totally didn't divide it by 120. I underlined this bad boy, and then I put my answer. That's rounded. She rounded significant figures. Okay, so with significant figures, you count at the beginning of the number. 1, 2. This is the one that may or may not change. We look at the digit just 3 to the right of it, because that's a 6. That now becomes a 2. But 116.619 wouldn't round to 12. So you must have a 0 and a, remember what they're called? No, placeholder. No, that's 3 digits, sweetheart. 117 is 3 significant figures. Oh, okay, makes sense. That's a good recap of significant figures as well. Right, B. We need to find, what does all this mean? Funny symbol BCA. What does that mean?
Finding the angle C.
Okay, good. Okay, so are we good with that? So it's from B to C to A. From B to C to A. So we want this. We want this angle here. So I'm going to put a theta in there, because that's what I like to use as an angle measure. You can use whatever you like. Now, resketching it can often help. So I'm now going to put my labels in. I know this is 190, and I know this is 150. Now, secretly, I also know this is 120. Now, the reason I would avoid using this, if you possibly can, is why. Why might you suggest I avoid using that, Laura? In case it's wrong. Okay, because if you use that and it was wrong, you're going to mess everything else up. Now, sometimes you can't avoid using the one you've worked out. But if you can avoid it, let's do that.
Do you know that EAC is 90?
You checked too because it said this was horizontal and that's a wall. You're assuming a wall is vertical.
It says a vertical wall.
There you go.
Wait, so BAC, you know there's 90.
Yeah.
Is it, don't you just know that because it's a right angle?
Yes, but what Hannah's saying is they didn't say it's 90 degrees, but we have to assume it is.
So it's a right angle.
Yeah. All right. Okay. So how are we going to do this? Layla, can you help me out? What's our first step when we do these kinds of questions? We know this length, but we're going to ignore that. Just because we've given these two. So what did these two both tell me at the beginning of the lesson when I said, what did we do first? And I said, oh, I've drilled it into all of you. Yep, label size with which letters? Yep. Which one's which? Nice. Yeah. Lovely. So Tanya, which of those three is irrelevant for this question? Yeah. Samantha, what does that mean? Which trig identity am I going to use? Car. Amelia. What am I going to write now? So remember, I'm trying to find my angle. So which of my three letters, the C-A-H, do I cover up? Remember, we cover up one of the letters to decide how to write.
C.
Why the C? You're correct.
Because you know A and H. So that's what you gotta work on.
Perfect. And the C stands for
Who?
which always goes with the angle. Yes? So we would cover up the C, we'd write cos theta equals A is up in the air, so it's A over H. So cos theta is equal to, Alexis, what?
0.789.
Oh, I was going to numbers.
What are the numbers?
What are the numbers?
Oh, 150 or 180.
Chris,
Isn't this the cost line?
well, Emma, I was going to come to someone next and seeing as you start talking about it. Sure. Why did you say cos minus 1?
We're figuring out.
Good, because we're finding an angle, we have to undo the cos part, so it's going to be cos minus 1 of whatever answer that was. What mode do we need to make sure our counts are in?
Degree.
Trace the end.
It's 37.8636466.
You don't like rounding at all, clearly.
I'm just telling you, how much do you want?
I don't know, what does it say in the question?
I don't know.
Equally, read the words.
So it was 37.863.
Hey, Skill, what does it say in the question?
10 to the nearest degree. So then, is it just 38?
Yes. Yeah.
Wait, but why did we decide to cover up C?
Hey, why did we decide to cover up C? Amelia, you told me first, so you can tell Emma.
Because you know the numbers of A and H. So those are the
Because in our triangle, we know the values for A and H.
Okay.
So remember that the whole idea of covering something up is because we're covering up what we're missing. Yes. And additionally to that is that the C stands for cos, which has to be attached to the angle. So if you're trying to find an angle, you'll always be covering up the C, the T, or the S.
Oh yeah, so it's always just A over H or
O over H.
Okay, you could just said that was easy.
I'm sorry. No, but it's just so much. Okay, so now they've asked for A, B, C. And what's the easiest way of doing this one? Ashley?
180 equals 90 plus 30. So, 90, yes. Sorry. 180 minus, then bracket, 90 plus 30 plus 14.
Perfect. Initially you had a few equals in there.
Yeah.
So, we know the angles in a triangle add to 180, so we know that the other angle, I forgot what it was, ABC, is going to be 180, subtract those two bad boys added together. When I say those two bad boys, obviously, I'm talking about 90 as one of them. So that's 180, subtract 128.
Could you keep the decimal places or not?
Well, they've also asked for this to the nearest degree, so you can use your rounded version. Okay. There we go. Now, next couple talk about phrases that we sometimes see in questions. Should I go towards this? This bit here talks about angle of elevation and angle of depression. Okay? Elevation means rising, you're elevating, you're going up. Yes? And depression means you're going down. Okay? So, this diagram here is the best way of looking at it. So it's always going to be geared around the horizontal. And elevation would obviously be going up, depression would be going down. Now, the reason that we bring this into play here is that sometimes they're not necessarily going to talk about this angle here, this angle of depression. Sometimes they might talk about something else. We know this is horizontal. We're also assuming that this leg here is horizontal. What I know is the connection between this angle and this angle. They're equal. What time? Yes, that's right. They're alternate angles. Yes, you see that? So sometimes that's going to come into play when you're doing these kinds of questions. Okay, so they may ask about the angle. Anyway, they may ask about certain things, but you need to remember that these two angles are equal to each other. So in your diagram, you may be able to work out this, but they've asked you about the angle of depression. Well, you know that means it's the same as this one you've just been able to work out. Does that make sense? Okay. Oh, and here, they've got this in the diagram here, that the angle of depression up here is obviously the same as the angle of elevation down here. Right. Oh, got a lot of work to do. Let's do it.